May 19th, 1942, Dinjan airfield, Assam Province, India. Captain Robert Terrill stood beside a Douglas C-47 Skytrain, watching Burmese refugees load tea crates into the cargo bay while monsoon rain hammered the aluminum fuselage. The airplane was a civilian airliner converted for military transport, powered by two Pratt and Whitney engines that produced 1,400 horsepower each, carrying a payload, the manufacturer said, should never exceed 6,000 pounds under optimal conditions. Terrill's orders required him to carry 10,000 pounds of ammunition and medical supplies over the Himalayan mountains to Kunming, China. The route crossed terrain where peaks reached 20,000 feet, where weather changed from clear to deadly in minutes, where Japanese fighters patrolled the valleys, and where every pilot who had attempted the crossing in the past month understood they were flying missions that violated every safety principle Douglas aircraft had, written into the operations manual. The Germans had watched American transport doctrine since 1940 and dismissed it as typical American excess. Big, slow, unarmed cargo planes that required air superiority to operate, useful for moving supplies between rear areas, irrelevant for actual combat operations. Luftwaffe intelligence assessed the C-47 as a converted civilian design, too heavy, too slow, too fragile for operations in contested airspace or extreme conditions. When German military attaché reports reached Berlin describing American plans to supply China by flying cargo planes over the Himalayas, the analysis was unanimous. Impossible. The aircraft lacked the power. The crews lacked the training. The entire concept defied basic aviation principles. You could not fly transport aircraft designed for Kansas over mountains higher than most bombers could reach, through weather that killed experienced pilots, carrying loads that exceeded structural limits. The Americans would try, the Americans would fail, and German strategists would be proven correct about the limits of American aviation doctrine, except the Americans did not fail. They flew more than 33,000 tons of supplies over the Himalayas in 1943. They flew 85,000 tons in 1944. By war's end, they had delivered 650,000 tons through a supply route the Germans said could not exist. The C-47 proved to be exactly wrong for the mission in every way that mattered on paper, and exactly right in every way that mattered in combat. The story of how that happened begins not in India or China, but in California in 1935, with an airline executive who believed passengers would pay extra for comfort and an engineer who figured out how to sell that comfort for profit. September 19th, 1935. Douglas Aircraft Company, Santa Monica, California. Donald Douglas sat in his office reviewing American Airlines specification for a new passenger transport. The airline wanted something bigger than the DC-2, something that could carry 21 passengers overnight from New York to Los Angeles, with berths for sleeping, something comfortable enough that businessmen would choose air travel over trains. The specification was straightforward commercial aviation, but Arthur Raymond, Douglas's chief engineer, saw something else. He saw a fuselage that could be modified for cargo. He saw engines reliable enough for extended operations. He saw a design simple enough that airlines could maintain it without factory support, and simple enough that it could be built in large numbers if war came. Raymond had watched European rearmament since Hitler took power in 1933. He understood that airlines would be converted to military transport if war began, and military transport needed aircraft that could survive rough handling by minimally trained crews. The DC-2 had proven the basic design concept: twin engines, low-wing monoplane, all-metal construction. The new transport would be larger, more powerful, and built to the same rugged standards that had made the DC-2 popular with airlines that flew routes through bad weather and primitive airfields. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The DC-3 first flew on December 17th, 1935. Wingspan 95 feet, length 64 feet, two Pratt and Whitney R-18 30 twin Wasp engines producing 1,000 horsepower each. Cruise speed 190 miles per hour. Range 1,500 miles with full payload. Service ceiling 23,000 feet. The aircraft could carry 21 passengers in sleeper configuration or 28 in standard seating. American Airlines began passenger service in June 1936. The DC-3 was faster than trains, more comfortable than previous aircraft, and profitable enough that airlines could make money on passenger routes that had previously required government mail contracts to break even. By 1939, DC-3 seconds carried 90% of commercial air traffic in the United States. The military applications were obvious to anyone who understood logistics. The Army Air Corps had been watching the DC-3 since its first flight. They ordered their first military variant in 1936, designated C-47 Skytrain. The differences from the civilian DC-3 were modest but significant. Reinforced cargo floor capable of handling military loads, large cargo door in the port side aft fuselage, strengthened tail section for glider towing. No passenger amenities, just cargo tie-downs and troop seats. The engines were military-spec Pratt and Whitney R1830s, producing 1,200 horsepower each, later increased to 1,400 in improved models. Maximum cargo capacity was listed as 6,000 pounds, though that figure assumed paved runways and normal operating conditions. The C-47 was designed for moving troops and supplies between rear area bases under conditions where air superiority was guaranteed and weather was manageable. It was not designed for combat operations. It was not designed for extreme altitude. It was not designed to be overloaded by 60% and flown through mountain passes at night. The Army bought them anyway because the United States military in 1939 understood it would need transport aircraft in large numbers for any future war, and the C-47 was available immediately from a production line already tooled for civilian DC-3 seconds. By December 7, 1941, the Army had 400 C-47 seconds in service. Douglas Aircraft was producing them at a rate that would reach more than 10,000 by war's end. No other nation had transport capacity on that scale. Germany's Junkers Ju-52 could carry fewer troops, flew slower, and required 3 engines to do it. British transport aviation depended largely on impressed civilian aircraft. Japan had no equivalent cargo aircraft in meaningful numbers. American transport doctrine was built around the assumption that cargo planes would operate in rear areas protected by friendly fighters, moving supplies from secure bases to other secure bases. The doctrine assumed paved runways, or at minimum improved airstrips. It assumed weather forecasting and ground-based navigation aids. It assumed maintenance facilities and spare parts supply chains. The doctrine was entirely conventional and entirely reasonable. Then the Japanese conquered Burma, April 29, 1942. The last British forces withdrew from Burma, leaving the Burma Road, the single overland supply route from India to China, in Japanese hands. China's nationalist government under Chiang Kai-shek had been fighting Japan since 1937, supplied through the Burma Road and through ports that were now also occupied. With Burma lost, China was isolated. No ports, no roads, no way to receive the weapons and supplies the United States had promised. The strategic implications were immediate. If China collapsed, Japan could shift divisions from the Chinese theatre to the Pacific or to Southeast Asia. The entire Allied strategy in Asia depended on China continuing to tie down Japanese forces. But China could not continue without supplies, and there was no conventional way to deliver those supplies. Lieutenant General Joseph Stilwell, commander of American forces in the China-Burma-India theatre, faced a logistics problem that had no textbook solution. The only possible supply route was over the Himalayan mountains, flying from India to China over terrain the pilots were already calling the hump. The term was darkly ironic. The hump was not one mountain but an entire range system extending 500 miles, featuring peaks above 20,000 feet, valleys controlled by Japanese fighters, and weather so violent it could tear aircraft apart in flight. British pilots who had flown the route in small numbers said it was the most dangerous regular air route in the world. They said it could not be done in the numbers required to sustain Chinese resistance. They said American transport pilots, trained on the flat, safe airways of the continental United States, would die in large numbers, attempting missions that required mountain flying skills they did not possess. Stilwell listened to the British assessments and reached his own conclusion. The route was impossible by any conventional measure, but conventional measures had stopped applying the day Japan cut the Burma Road. The United States would fly the hump because there was no alternative, and they would fly it in C-47 seconds because C-47 seconds were what they had. The first transport unit assigned to the route was the India-China Ferry Command, later reorganized as the Air Transport Command Hump Operation. The initial aircraft allocation was 25 C-47 seconds. The crews were young pilots, most with fewer than 500 hours total flight time, trained on flat land routes in perfect weather. Their introduction to Himalayan flying was 8 hours of lectures on mountain weather, hypoxia symptoms, and emergency procedures, followed by one orientation flight with an experienced pilot, if an experienced pilot was available. Then they were assigned their own aircraft and told to start flying cargo to China. The operations manual for the C-47 specified maximum gross takeoff weight of 26,000 pounds. That figure assumed paved runways at sea level in normal temperature conditions. Dinjan airfield sat at 300 feet elevation in a climate where temperatures exceeded 100 degrees Fahrenheit in the dry season. The runways were grass and packed dirt, deteriorating to mud during monsoons. The aircraft needed to carry enough fuel for the 500-mile flight to Kunming plus reserves for weather diversion and emergencies. Fuel alone weighed 5,000 pounds. The cargo requirement was 10,000 pounds of ammunition, weapons, vehicle parts, whatever China needed most urgently. Total weight, 36,000 pounds. 10,000 pounds over maximum gross weight. Takeoff distance at that weight exceeded the available runway length. The aircraft would need every foot of grass to stagger into the air and would have to begin climbing immediately to clear the foothills that began 5 miles from the end of the runway. This was not normal operations. This was test pilot flying, except the test pilots were 23-year-old cargo haulers who had been trained to fly straight and level between cities with navigation beacons. The German military attaché report from New Delhi reached Berlin in June 1942. The Americans were attempting to supply China by air using twin-engine transport aircraft over mountains that reached 20,000 feet. The assessment was detailed and professionally skeptical. The Douglas C-47 had a service ceiling of 23,000 feet at normal weight. Overloaded, that ceiling would drop to perhaps 20,000 feet. The hump route required crossing ridges above 15,000 feet, with peaks rising to 20,000 on both sides. The aircraft would be flying at the absolute limit of their performance envelope, with no margin for weather, mechanical problems, or navigation errors. Weather in the region was unpredictable and violent. Monsoons from June through September brought thunderstorms that reached 50,000 feet with turbulence capable of destroying bombers. Winter brought clear skies, but also brought winds above 100 miles per hour at altitude and icing conditions that could add tons of weight to an airframe in minutes. The Japanese held the valleys and regularly sent fighters to patrol the lower altitude routes. American pilots would be forced to choose between flying high, where their overloaded aircraft barely flew, or flying low, where Japanese interceptors could reach them. Luftwaffe analysts calculated survival rates based on European transport operations. They estimated 30% losses within the first 6 months. They predicted the Americans would abandon the effort by winter, when weather made the route completely impassable. They were wrong about the timeline, but not entirely wrong about the losses. May through August 1942, the India-China Ferry Command lost 12 C-47 seconds. Crashes on takeoff when overloaded aircraft could not clear the hills. Crashes in thunderstorms when turbulence exceeded the structural limits. Crashes into mountains when navigation errors put aircraft into terrain they could not see. Controlled flight into terrain, the bureaucratic term for flying into a mountain that killed you. The crews learned through experience that killed of their friends. They learned that the C-47 could be overloaded to 36,000 pounds if you used every inch of runway, and accepted that abort speeds were theoretical. Once you committed to takeoff, you were taking off or dying. They learned that the engines would overheat on climb-out unless you enriched the mixture and accepted the massive fuel consumption penalty. They learned that ice accumulation above 15,000 feet required constant adjustment of throttle and trim to maintain flying speed, and that if ice built up too fast, you had minutes to descend below the freezing level before the aircraft became uncontrollable. They learned which valleys offered the best weather, and which valleys were death traps where downdrafts could drive you into the ground faster than you could climb out. They learned to read cloud formations and to avoid the towering cumulus build-ups that marked the worst thunderstorms. They learned to fly at night without lights because Japanese night fighters patrolled the moonlit routes. And they learned that the C-47 could take damage that should have been catastrophic and still bring you home. The aircraft that the Germans had dismissed as too fragile for combat operations absorbed punishment that destroyed fighters. Turbulence that bent wing spars, ice loads that should have exceeded structural limits, battle damage from Japanese interceptors that found them at low altitude, engine failures that forced single-engine flight over mountains where single-engine service ceiling was below the terrain height. The C-47 kept flying, the crews kept flying, and the tonnage kept increasing. By September 1942, the hump operation was moving 500 tons per month to China, not enough to sustain major offensive operations, but enough to keep Chinese forces in the field. The German assessment revised its predictions. The Americans had survived the initial learning curve, but winter weather would stop them. The monsoons, it were dangerous, but winter in the Himalayas was impossible. Ice, wind, and reduced visibility would ground the transport fleet or kill it. They were half right. December 1942 through February 1943, the hump operation recorded its highest loss rates. 23 C-47 seconds were lost in 3 months, but tonnage did not decrease. It increased. More aircraft arrived to replace losses. More crews arrived to replace dead pilots. The Americans were applying industrial logic to an aviation problem. Losses were acceptable if production exceeded losses. Crew casualties were acceptable if training programs produced more pilots than combat consumed. This was not German operational doctrine. This was not any European powers doctrine. This was American logistics warfare, treating human lives and aircraft as resources to be expended in pursuit of strategic objectives. The calculation was cold, and the results were effective. By March 1943, the hump operation was moving 2,000 tons per month. By June, 4,000 tons. The C-47 seconds were now operating in formations, following lead navigators through the valleys, climbing to altitude in trail formation to conserve fuel. The overload limits had been abandoned entirely. Aircraft regularly took off at 38,000 pounds, 40,000 pounds, whatever weight the engines could pull off the runway. The safety margins written into the operations manual no longer applied. The manual was for peacetime operations between cities with paved runways and maintenance facilities. The hump was something else entirely. The Germans received updated intelligence reports and revised their assessment again. The Americans had succeeded beyond any reasonable expectation, but they were paying a terrible price. The loss rates were unsustainable. Eventually, crew morale would collapse or the aircraft would simply wear out. The C-47 airframe was designed for civilian airline operations, perhaps 10,000 hours of service before major overhaul. Hump operations were accumulating flight hours at triple the normal rate, under conditions that exceeded design limits on every flight. The aircraft should have been falling apart. Some were. Maintenance crews at Dinjan and the other hump bases worked around the clock, replacing engines, patching battle damage, and repairing structural damage from turbulence. They cannibalized crashed aircraft for spare parts. They improvised repairs using materials never intended for aircraft. They kept the fleet flying through expertise and determination, and by ignoring regulations that said certain types of damage required aircraft to be grounded until factory-certified repairs could be performed. There were no factories in Assam Province. There was only the mission and the aircraft that could fly it. By September 1943, the operation had expanded beyond C-47 seconds. Larger four-engine C-54 seconds and C-46 commandos were supplementing the fleet. But the C-47 remained the backbone of the operation because the C-47 could land on short primitive strips where larger aircraft could not. Chinese forces operated from dozens of small airfields scattered through the interior. The C-47 could reach them. Nothing else could. The final accounting of the hump operation would reveal statistics that vindicated American transport doctrine and invalidated German assumptions about what transport aircraft could do. Total flights, more than 155,000. Total tonnage delivered, 650,000 tons. Total aircraft losses, 594 from all causes. Loss rate, approximately 0.3% per sortie. In European theatre, bomber loss rates averaged 3 to 6% per mission. The hump operation was losing aircraft at 1/10 the rate of combat bombers, while flying unarmed transports through the most dangerous terrain in the world. The Germans had been correct that the C-47 was a converted civilian design. They had been correct that it was not designed for extreme altitude or overload operations. They had been correct that the hump route was the most dangerous regular air route in the world, but they had been wrong about what those facts meant. The C-47 succeeded not despite being a civilian design, but because it was a civilian design. It was simple, rugged, and maintainable under primitive conditions. The engines were proven reliable in airline service. The airframe was forgiving of rough handling. The flight characteristics were docile enough that minimally trained pilots could fly it safely under conditions that would have killed them in more demanding aircraft. And most critically, the Americans had built more than 10,000 of them, which meant losses could be replaced faster than combat consumed them. This was American industrial warfare applied to aviation. Build a simple design in overwhelming numbers. Accept higher loss rates, because you can replace losses. Train crews adequately rather than perfectly, because adequate crews in sufficient numbers defeat perfect crews in limited numbers. Use the aircraft beyond design limits, because the strategic objective justifies the cost. The German military doctrine could not comprehend this approach, because German doctrine assumed limited resources and therefore demanded maximum efficiency from every asset. The Americans assumed unlimited resources and therefore demanded maximum effectiveness regardless of efficiency. Both approaches were rational within their respective strategic contexts. But in the Himalayas, in 1942 through 1945, the American approach delivered 650,000 tons of supplies through a route the Germans said could not exist. The human cost was 594 aircraft and approximately 1,000 American aircrew killed. The strategic result was that China remained in the war, tying down more than 1 million Japanese troops that could not be deployed to the Pacific theatre. The C-47 that the Germans had dismissed as too flimsy for combat operations had performed one of the most demanding sustained airlift operations in military history, and it had done so while carrying loads that exceeded its rated capacity by 60% over mountains higher than its service ceiling, through weather that killed experienced pilots, with crews who learned mountain flying by surviving their mistakes. December 19th, 1944, Kunming Airfield, China. Captain Robert Terrill shut down his C-47 after his 211th crossing of the hump. The aircraft had accumulated 3,200 hours of flight time in 18 months. The engines were past their recommended overhaul interval. The airframe had stress cracks in the wing roots. The hydraulic system leaked. The electrical system was held together with improvised repairs. By every conventional standard, the aircraft should have been grounded pending major maintenance. But conventional standards had stopped applying the day the Burma Road was cut. Terrill and his crew would fly again tomorrow, carrying another 10,000 pounds of ammunition to Chinese forces advancing against Japanese positions. The Germans had been right that the C-47 was wrong for the mission. They had been wrong about what that meant. The mechanics who kept those aircraft flying understood something the German analysts missed entirely. The C-47 was not designed for the hump, but its design philosophy made hump operations possible. Douglas Aircraft had built the DC-3 for airlines that needed to make money, and airlines made money when aircraft spent time in the air rather than in maintenance hangars. Every system was designed for accessibility and simple repair. The engines were Pratt and Whitney R-1830s, the same engines that powered dozens of other American aircraft types. Parts were interchangeable. Maintenance procedures were standardized. A mechanic trained on one R-1830 could work on any R-1830. The airframe used conventional aluminum construction with riveted skin panels. Damaged sections could be cut out and replaced without specialized tooling. Battle damage that would have grounded more complex aircraft could be patched overnight with materials available at forward bases. The hydraulic system was simple enough that leaks could be traced and fixed by mechanics with basic training. The electrical system used standard components that could be scavenged from wrecked aircraft. There was nothing revolutionary about the C-47's engineering. That was precisely what made it revolutionary for sustained operations under primitive conditions. The aircraft did not need factory support or specialized facilities. It needed mechanics with basic skills and enough spare parts to keep critical systems functioning. The hump bases had both. Staff Sergeant William Chen had been an airline mechanic in San Francisco before the war, working on United Airlines DC-3 seconds at Oakland Airport. In October 1942, he found himself at Dinjan airfield in Assam Province, responsible for keeping 6 C-47 seconds flyable under conditions that would have horrified his civilian supervisors. The aircraft returned from each mission with damage that accumulated faster than his crew could repair it. Engine cowlings cracked from repeated overstress during overweight takeoffs. Wing spars developed stress fractures from turbulence loads that exceeded design limits. Landing gear struts were compressed beyond specifications from repeated hard landings on primitive Chinese airstrips. The official maintenance regulations required detailed inspections and factory-certified repairs for each category of damage. Chen's solution was simpler and more pragmatic. He categorized damage into 2 types: damage that would kill the crew on the next flight, and damage that probably would not. The first category got repaired immediately, using whatever materials and methods would keep the aircraft safe. The second category got deferred until the aircraft could be rotated out of service, which might be weeks or months depending on operational tempo. This was not negligence. This was rational triage under combat conditions, where perfect maintenance was impossible and adequate maintenance kept the supplies flowing. Chen's crew worked 12-hour shifts, often longer when multiple aircraft returned with serious damage. They worked through monsoon rains that turned the airfield into ankle-deep mud. They worked through 100-degree heat that made metal too hot to touch with bare hands. They worked by flashlight at night because the base had no floodlights for the maintenance area, and they kept aircraft flying that, by every regulatory standard, should have been grounded. The pilots understood what the mechanics were doing and trusted them absolutely. When Chen signed off and on an aircraft as flyable, pilots accepted that assessment even when they could see the patches and improvised repairs. They had no choice. The mission required flying aircraft that were not in perfect condition, and the alternative to flying was letting China collapse. Lieutenant James Harrison had been a crop duster in Nebraska before the war, flying Stearman biplanes over cornfields at 200 feet, learning to read wind and weather by watching how dust moved across fields. In January 1943, he was assigned to the hump operation with 300 hours of total flight time and exactly 0 hours of mountain flying experience. His first crossing was in the right seat with an experienced captain who had survived 4 months on the route. The experienced captain's advice was brutally simple. Stay out of the big clouds. Watch your airspeed, because if you stall at altitude, you will fall 5,000 feet before you recover. If you get ice, descend immediately even, if that means flying through valleys where Japanese fighters patrol. If an engine fails, accept that you are probably going to crash and focus on making it a survivable crash rather than a fatal one. And never believe the weather forecasts, because the weather over the hump changes faster than forecasters can track. Harrison absorbed this information and understood that his crop-dusting experience, flying low and slow while watching weather develop, was better preparation for the hump than the instrument training he had received at flight school. The hump was not about precise navigation or smooth flight. It was about keeping a barely controllable aircraft pointed in approximately the right direction while avoiding the things that would kill you immediately, so you could deal with the things that might kill you later. His first solo crossing was on January 23, 1943. Weather briefing predicted clear skies over the route. Harrison took off from Dinjan at 0600 hours carrying 9,000 pounds of ammunition and spare parts. The C-47 used every foot of the grass runway to stagger into the air at 35,000 pounds gross weight. He climbed slowly, the engines howling at maximum continuous power, watching the foothills approach and wondering if he would clear them. At 5,000 feet, with the hills still rising ahead, he had just enough altitude to cross the first ridge. The textbook called this a safe margin. Harrison called it terrifying, and he had another 400 miles to fly. The weather forecast was wrong by 0730 hours. A weather front that was supposed to be 50 miles south had moved north overnight. Harrison flew into cloud at 12,000 feet and immediately encountered turbulence that threw the C-47 around like a toy. He fought the controls, trying to maintain heading, but the turbulence was too severe. The aircraft rolled 40 degrees left, then 60 degrees right. The artificial horizon tumbled and became useless. Harrison was flying blind in turbulence that exceeded anything he had experienced in Nebraska thunderstorms. The crop duster instincts took over. He reduced power to avoid overstressing the airframe. He stopped trying to maintain altitude and focused on keeping the wings approximately level. He accepted that the turbulence would throw him wherever it wanted, and his job was just to survive until it spit him out. For 15 minutes, the C-47 climbed and dove and rolled through a storm cell that probably reached 40,000 feet. Harrison had no idea where he was. The compass was spinning. The artificial horizon was useless. He was flying by feel and by instinct, keeping the wings level enough that the aircraft did not invert, keeping the nose high enough that he did not build up speed that would tear the wings off. Then the turbulence stopped. The C-47 broke out of the cloud at 16,000 feet into clear, cold air. Harrison checked his heading and realized he was flying west, back toward India, at least 30 miles off course. He turned northeast, reset the compass, and continued toward China. The mission had another 200 miles to run. That crossing taught Harrison something that would keep him alive through 97 more missions. The weather would try to kill him on every flight, but the C-47 could survive conditions that would destroy him if he was flying something less forgiving. The aircraft wanted to fly straight and level. If he let it fly, it would survive. If he fought it, if he tried to force it through conditions it could not handle, he would die. This was the essential difference between the C-47 and more demanding aircraft. It forgave pilot errors. It absorbed punishment. It kept flying when textbook procedures said it should not fly. By spring 1943, the hump operation had developed into something that resembled a system rather than a series of individual heroic missions. The route structure was formalized. Aircraft followed designated airways through the valleys where weather was most predictable. Lead navigators with the most experience flew at the front of formations. Less experienced pilots followed in trail, learning the route by repetition. Radio navigation aids were installed at key points along the route, though they worked intermittently and could not be trusted completely. Weather reconnaissance aircraft flew ahead of transport formations, radioing back conditions and advising on altitude and routing. The Japanese responded by increasing fighter patrols along the known routes. They positioned observers on mountain peaks to radio warnings when American formations approached. They developed tactics specifically for attacking overloaded transports. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The C-47 was slow, unarmed, and could not maneuver aggressively when loaded to 40,000 pounds. Japanese fighters, primarily Ki-43 Oscars and Ki-44 Tojos, could reach the altitudes where transports flew and had the speed to overtake them easily. The American response was not to fight, it was to avoid. Pilots learned to recognize the glint of sunlight on Japanese fighters from miles away. They learned to use cloud cover for concealment. They learned which valleys offered the best escape routes when interceptors appeared. And they learned that the C-47, while slow and unmaneuverable, was tough enough to survive attacks that should have been fatal. First Lieutenant Robert Scott was flying his 42nd mission on June 7, 1943, when two Ki-43 fighters found his C-47 at 14,000 feet near the Burma-China border. Scott was flying alone, separated from his formation by weather. The fighters came out of the sun in a classic bounce, firing on the first pass, before Scott even knew they were there. 20mm cannon shells punched through the aluminum skin, destroying the radio, severing control cables, and wounding the co-pilot. Scott threw the C-47 into a dive, heading for the valley floor where he hoped terrain would limit the fighter's maneuvering room. The aircraft responded sluggishly. One aileron cable was severed. Rudder control was partial, but the engines were still running and the wings were still attached. The fighters followed him down, firing on each pass. More holes appeared in the fuselage. The cargo of medical supplies was shredded. Shell fragments ricocheted through the cabin, but the C-47 kept flying. At 6,000 feet, Scott leveled out and headed for the nearest American base, a forward strip at Yunnan that could handle emergency landings. The fighters made 3 more passes, expending their ammunition, then broke off. Scott flew another 40 minutes with partial controls, his co-pilot binding his own wounds, the aircraft leaking hydraulic fluid and fuel. He landed at Yunnan with the main gear, but could not extend the nose wheel. The C-47 settled onto the runway nose first, sliding to a stop in a shower of sparks. Scott and his co-pilot walked away. The maintenance crew counted 127 holes in the airframe. The aircraft was repaired and returned to service 3 weeks later. Stories like Scott's were not exceptional. They were routine. The C-47 absorbed battle damage that would have destroyed fighters. Pilots landed with engines shot out, with control surfaces damaged, with hydraulic systems failed. The aircraft kept bringing them home. By July 1943, German intelligence was receiving reports about the hump operation that contradicted everything their initial assessment predicted. The Americans were moving 6,000 tons per month over the route. Loss rates had decreased as pilots gained experience. The fleet was expanding rather than contracting. The German analysis was forced to conclude that American transport doctrine had succeeded under conditions where success should have been impossible. The conclusion was professionally stated and deeply troubling. The Americans possessed manufacturing capacity to replace losses faster than combat-consumed aircraft. They possessed training capacity to replace crew losses faster than combat-consumed crews. Most critically, they possessed an industrial design philosophy that prioritized reliability and maintainability over performance. The C-47 was inferior to German transport aircraft in speed, range, and payload, but it was superior in the characteristics that mattered for sustained operations under combat conditions. It was simple to maintain. It was forgiving to fly. It was rugged enough to survive damage, and it existed in numbers that made individual losses strategically irrelevant. The Luftwaffe had nothing equivalent. German transport aircraft were more sophisticated, more capable in theory, but more fragile in practice and available in far smaller numbers. The German military doctrine assumed limited resources and therefore could not contemplate operations where aircraft were deliberately overloaded and flown to destruction as routine procedure. The American doctrine assumed unlimited resources and therefore accepted losses that German commanders would have considered catastrophic. By August 1943, the hump operation was moving 10,000 tons per month to China. The operation had become the largest sustained airlift in history. More than 300 aircraft flying round the clock, more than 2,000 aircrew, maintenance crews working continuously to keep the fleet flying, supply chains stretching back to the United States to provide spare parts, engines, and complete replacement aircraft. The operation consumed resources at a rate that would have bankrupted any nation except the United States. Fuel alone required dedicating entire tanker ships to supplying Indian Ocean ports. Spare parts required establishing supply depots across India. Replacement crew training required diverting instructors and aircraft from other theatres. The cost was enormous. The alternative was losing China, which would have freed 1 million Japanese troops for deployment elsewhere. The calculation was simple. The execution was anything but. Winter 1943 brought the worst flying conditions of the entire operation. Winds at altitude exceeded 150 miles per hour. Ice accumulation was constant above 12,000 feet. Visibility was often less than a quarter mile. The peaks that pilots needed to clear were invisible until they were close enough to crash into. The standard procedure for winter operations was to climb to 20,000 feet and maintain that altitude until the navigation aids indicated you were past the high terrain. At 20,000 feet, the overloaded C-47 seconds were flying at their absolute ceiling. The engines were producing barely enough power to maintain altitude. Any disturbance, turbulence, ice accumulation, power loss would send the aircraft descending into terrain that was invisible below. Pilots learned to watch the manifold pressure gauges like their lives depended on those gauges, because their lives did depend on those gauges. Any drop in manifold pressure meant the engines were losing power. Losing power at altitude meant descending. Descending meant dying. Captain Frank Martinez flew through the worst weather of the 1943 winter season on December 19th. His C-47 was loaded to 39,000 pounds, carrying artillery shells to Kunming. The weather briefing predicted icing above 15,000 feet. Martinez took off, knowing he would be flying through ice for at least an hour. At 17,000 feet, the ice began accumulating on the wings and propellers. Martinez watched it build up, thick white ice, forming along the leading edges, changing the aerodynamic shape of the wing. The aircraft became heavier, the wings became less efficient, the stall speed increased. Martinez increased power to maintain altitude, but the engines were already at maximum continuous power. There was no more power available. The C-47 began descending, slowly at first, then faster as more ice accumulated. 19,000 feet. The peaks around him reached 20,000 feet. He was descending toward terrain he could not see in ice conditions that would kill him if he did not descend. Martinez made the decision that saved his life and killed others who chose differently. He descended deliberately, accepting the risk of flying low where Japanese fighters patrolled, to reach warmer air where the ice would melt. At 13,000 feet, the ice began shedding. Large chunks broke off the wings and propellers, some hitting the fuselage with sounds like gunshots. The engines smoothed out. The aircraft stopped descending and began climbing again. Martinez climbed back to 17,000 feet and continued to China. He learned later that 2 other C-47 seconds flying the same route that day had chosen to maintain altitude. Both crashed into mountains, killing all aboard. The winter of 1943 through 44 killed 41 C-47 seconds. But the operation did not stop. It expanded. By March 1944, the hump was moving 15,000 tons per month. New bases opened in China to receive the supplies. New routes were mapped through the valleys to reduce congestion and spread the risk. And new aircraft joined the operation, larger C-46 Commandos and C-54 Skymasters that could carry more cargo per flight. But the C-47 remained essential because only the C-47 could land on the short, rough strips where Chinese forces operated. The larger aircraft needed improved runways. The C-47 needed 1,000 feet of relatively flat ground and nothing more. By summer 1944, Chinese forces were advancing against Japanese positions using American weapons and ammunition delivered by air. Artillery pieces that had been disassembled in India were reassembled in China and put into action. Vehicles that had been driven to Assam were flown piece by piece to Kunming and rebuilt. Entire hospitals were transported, beds and surgical equipment and medications, carried across the Himalayas by aircraft designed to carry passengers between cities. The German assessment from summer 1944 acknowledged defeat. The Americans had accomplished what German doctrine said was impossible. They had sustained a major military operation using only air supply over terrain that should have made air supply impossible. The cost in aircraft and lives was higher than any European power would have accepted. But the cost was irrelevant, because American industrial production exceeded the losses. This was the fundamental difference between American and German military doctrine. The Germans optimized for efficiency because they had to. The Americans optimized for effectiveness because they could. Neither approach was inherently superior. Both were rational responses to different resource constraints. But in the Himalayas, the American approach delivered results the German approach could not have achieved. By December 1944, the hump operation was moving 46,000 tons per month. The route that Japanese conquest of Burma was supposed to close permanently had become the primary supply line sustaining Chinese resistance. The operation employed more than 700 aircraft and 10,000 personnel. It had developed its own maintenance infrastructure, its own supply chains, its own training programs for replacement crews. It had become an independent military operation on a scale comparable to entire air forces. The C-47 that began the operation, the supposedly flimsy converted airliner that German analysts dismissed as inadequate, had proven to be exactly what the mission required. Not the fastest aircraft, not the most advanced, not the most capable in any single metric, but the most reliable, most maintainable, most forgiving aircraft available in the numbers required. The final months of the war brought a shift in mission priorities. With Japanese forces in retreat and Chinese ports beginning to reopen, the hump operation gradually reduced in scale. By August 1945, when Japan surrendered, the operation was winding down. The final statistics revealed an operation that had exceeded every projection and contradicted every German prediction. 155,000 flights completed, 650,000 tons delivered, 594 aircraft lost from all causes, approximately 1,000 aircrew killed, loss rate 0.38% per sortie. The losses were substantial. 594 aircraft represented a significant investment in resources. 1,000 dead aircrew was a terrible human cost, but the strategic result was unambiguous. China remained in the war. Chinese forces, equipped with American weapons delivered by air, tied down Japanese divisions that could not be deployed to the Pacific theater. The Burma campaign, which was supposed to isolate China and force its collapse, instead forced Japan to defend a 1,000-mile front with resources it could not spare. The C-47 had not won the war alone, but it had enabled operations that changed the strategic balance in Asia. The aircraft that German intelligence dismissed as too fragile for combat had flown more combat missions under more demanding conditions than most German aircraft would face in the entire war. The mechanics who kept the fleet flying had performed miracles with inadequate tools and insufficient parts. The pilots who flew the hump had demonstrated that training and determination could overcome conditions that violated every principle of safe aviation, and the entire operation had proven that American industrial capacity, applied with wasteful efficiency, could achieve objectives that careful German planning said were impossible. After the war, the C-47 continued serving with air forces around the world. The design that was revolutionary in 1935 remained current through the 1970s. Some are still flying today, 80 years after the first DC-3 took flight. The aircraft that was built for airline profit proved adaptable to military necessity. The simplicity that made it economical for airlines made it maintainable under combat conditions. The ruggedness that made it reliable for passengers made it survivable for cargo pilots flying overloaded through the Himalayas. The German assessment of the C-47 was technically correct in every detail and strategically wrong in its conclusion. The aircraft was too heavy for its engines. It was too slow for modern warfare. It was too fragile for extreme conditions. It carried too little cargo for its size. Every criticism was accurate. Every criticism was also irrelevant. The C-47 succeeded because success was measured in tonnage delivered, not in theoretical performance specifications. It succeeded because American doctrine accepted casualties that European doctrine would have considered unacceptable. It succeeded because American industry could produce aircraft faster than the hump could destroy them. Most fundamentally, it succeeded because the mission required an aircraft that could survive being flown to destruction repeatedly, and the C-47 could survive what should have killed it. Captain Robert Terrill completed his final hump crossing on June 3, 1945. His C-47 had accumulated 4,100 hours of flight time. The airframe had cracks in the wing roots, the engines were past their second overhaul interval, and the hydraulic system required constant attention. By every standard, the aircraft should have been retired, but it was still flying because the mission required it to fly. Terrill shut down the engines at Kunming and walked away from an aircraft that had carried him safely over the Himalayas 247 times. He had seen crews die when their aircraft failed. He had seen crews die when weather killed them. He had seen crews die when Japanese fighters found them. But his aircraft, that specific battered C-47, had brought him home every time. The Germans had been right that the aircraft was wrong for the mission. They had been wrong about what that meant. The C-47 proved that the best aircraft for an impossible mission is not the most advanced aircraft or the most capable aircraft. It is the aircraft that keeps flying when every rational analysis says it should not. It is the aircraft that forgives the mistakes that kill pilots in less forgiving machines. It is the aircraft that can be maintained by mechanics working in mud with improvised tools. It is the aircraft that exists in numbers large enough that losses become acceptable rather than catastrophic. Douglas Aircraft built the DC-3 to make money for airlines flying passengers between cities. Arthur Raymond designed it to be simple and reliable. American mechanics kept it flying under conditions that would have horrified its designers. American pilots flew it beyond its design limits and survived because the aircraft forgave their mistakes. And American industrial capacity produced it in numbers that made the impossible routine. The hump operation delivered 650,000 tons of supplies through a route the Germans said could not exist. The C-47, that was too flimsy for combat, flew more combat missions under more demanding conditions than the sophisticated German transports that were supposedly superior. The aircraft that should have failed succeeded. The operation that should have collapsed expanded. The strategic calculation that said China would fall proved wrong. One aircraft design, one civilian airliner converted for military service, changed the balance of an entire theatre. Not through revolutionary technology or brilliant tactics or superior performance, through simplicity, reliability, and the willingness to fly machines to destruction in pursuit of strategic objectives. The Germans analyzed the C-47 and concluded it could not do what the Americans said it would do. The Americans flew the C-47 and proved that what you can analyze and what you can actually accomplish in combat are two completely different things. 6,500 pounds over maximum gross weight, 20,000 feet over the highest mountains in the world, 300 miles through weather that killed experienced pilots, no weapons, no armor, no protection except altitude and luck. The C-47 flew the hump because the mission required it and because American doctrine said an aircraft was just a tool to be used until it broke and then replaced. The Germans understood aircraft as precision instruments to be maintained and preserved. The Americans understood aircraft as expendable resources to be consumed in achieving objectives. Both philosophies were rational. Only one delivered 650,000 tons of supplies through the Himalayas. The C-47, that should not have succeeded, proved that sometimes the wrong aircraft flown by determined crews, supported by unlimited industrial capacity, can accomplish what the right aircraft cannot. The Germans learned this lesson too late to matter. The Americans proved it every day for 3 years over the hump. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.